Now, how about directivity is given, but can we go ahead and define gain? This gain is related to directivity, but also in terms of how much of the power is accepted by the antenna. So there is not only a radiated power. When I feed in an antenna with an input power, some of it is reflected back, some of it is accepted by it. But all the power that is accepted by it doesn't mean gets radiated. There could be some power that is lost. This guy is lost. We want to reduce as much as loss as possible. We want to reduce as much as reflection possible. Whatever we feed in, we want the antenna to accept all of it and radiate it all. So this gain quantifies how much is the radiated power to the accepted power. So we will see that in a moment, what the definition is. But to connect that, we need to define this new term called as the efficiency of the antenna, which quantifies how much of the input power is effectively being used for radiation. There could be a mismatch, there could be a loss, and not all that is fed in is going to be radiated, right? So how much factor? If it is 100%, then it's very good. That means nothing is reflected back, nothing is absorbed, all of it is radiated. So you can define the radiated efficiency as the total power radiated over the total power that is fed in. And this factor, the 100% is good law. That means radiated is already what is in. But then, as I said, the input is having a mismatch, because here you can clearly see the accepted power is 1 minus gamma A square, the input. If you remember back from our transmission line. So this input, I can write this input in terms of the accepted power this way. And this accepted power has two components to it. One is the absorbed power and the other one is the radiated power. So you have radiated power, absorbed power, and the radiated power terms there. So this gain is related to the directivity through this efficiency here. So given an antenna's gain, you can figure out the directivity if you know how much is this mismatch, or given the directivity, you can find out the gain once you know the efficiency. So point to be noted, when there is no ohmic loss, if you can ignore the ohmic and dielectric losses, then your power absorbed is equal to 0. This is only when you ignore those losses. When you ignore those losses, your efficiency is same as 1 minus gamma square law, the mismatch. How much is the mismatch? 1 minus gamma A square. So your gain becomes simply the efficiency times directivity.